Given a couple of matrices, A and B, and we're asked to show that they multiply to give a multiple of the identity matrix. So I'm going to create a bit of space down here. Now you could potentially put this into your calculator, but I think it's probably quicker by hand. And remember, like I always use my fingers for this, but it's going to be 1 times minus 1 plus 2 times 2. I'm going along this first row and down the first column. You might be confident enough to just write the answer straight down, which is absolutely fine. Minus 1 plus 4, which is going to give 3. And then we go along the first row again, but down the second column. So 1 times 2 plus 2 times minus 1. Which is going to give 0. That's reassuring because we're trying to get a multiple of the identity. So you can almost, you know that it's going to be 3 and 0 now here, but let's just check it. Then we go along the second row and down the first column. So 2 times minus 1 plus 1 times 2. Yep, that's going to give 0. And then finally, second row, second column, 2 times 2 plus 1 times minus 1, which is going to give us 3. So this is then equal to 3 times 1, 0, 0, 1, which is equal to 3 times the identity matrix. M is a constant to be determined. I'll just say that M is equal to 3. On to the next part. We're given two matrices, 3 by 3 this time, and we're asked to show that the inverse is equal to K, inverse of C is equal to K times D, where K is a constant to be determined. Now you've got two options here. You can either actually find the inverse of C using your calculator, or we can multiply the left-hand side of both by C, which means that I want to show that if this is true, then the identity matrix would be equal to K times CD, which means that CD would be 1 over K times I. So I can use my the same sort of method as part 1 and just multiply C and D together. We're going to get something that's a multiple of I, and then I'll be able to get the result from there. I'll just have to work backwards. So CD. Now I've talked about how we do matrix multiplication, so I'm going to do a little bit quicker this time. 2 times, I will actually show my worker node. 2 times minus 4, minus 8, minus 5. Do you know what? No, I will do it. Minus 8, minus 5, minus 8, minus 5 plus 15. And then 16, it's the 2 times the 8. I'm going down this column. 16 plus 9 minus 25. And then minus 4, minus 1, plus 5. It might actually be worth just simplifying it as we go. So for this one, I'm going to end up with 2, and then 0 and 0. So that's good because we're trying to remember get a multiple of the identity. And you can almost see that now we're just going to get 2 times the identity, but I'm going to still go through the process. So minus 4, because now I'm using this column, this row, and times them by this column. So minus 4, minus 5, plus 9, which is going to give me 0. Then 8 plus 9 minus 15. It's going to give me 2 again. Minus 2, minus 1, plus 3. Okay, you get the idea. If you finish it off, you're going to get 0, 0, 2, which is 2 times I. And therefore, because remember we're asked to show the inverse was equal to, I'm not quite done, the inverse was equal to KD. So therefore, a half CD is equal to I, implies the inverse, if I multiply the left-hand side of both by the inverse, I'm going to get on the right-hand side the inverse times I, which is just the inverse, and then that will equal a half D as required. And then I can say that K is equal to a half. Right, it's important to be able to do that multiplication, so I'm glad we did it that way. The other way is to simply find the inverse of C. To be fair, it is probably a little bit quicker. So we go to matrix on our calculator. Definitely don't just do it inverse like by hand. Okay, and then do you know what? I'm going to call it matrix C. Why not? We've got 3 rows, 3 columns. Just type it in. And then I've got matrix calculations, back to options, matrix C. I want to find the inverse. There we go, -2, 4, -1. -2.5, 4.5, -0.5. And then 1.5 minus 2.5, 0.5. So then we can see that if I compare them, then the inverse of C, I just need to times the inverse by 2 to get to D. So I need to halve D to get to C. And that would also get us K is equal to a half. Finally, part 3. Okay, this one is forcing us to do it by hand rather than calculator because we've got K in there. Determine any matrix F for which EF is minus 2K6. And I've got to be honest, when I saw this, I thought it just wants any matrix, so just one that works. But in fact, it wants us to find all matrices. Now, this was the sample paper. I feel like that would have been kind of made a little bit clearer in a real exam paper. So I'm going to change it now to all matrices F, if that's what it's interested in. So let's work out EF. So I'm going to do the same kind of multiplication, go along first row, down the one column that we have, which will give 2k plus k cubed. And the bottom, I just get 2 times 3 plus 0k, I'm going to get 6. And I want that to equal minus 2k, 6. So the bottom is always okay. What I require is that the tops are the same. Which means we've got k cubed plus 4k is equal to 0. Factorize out the k. So k equals 0, or k squared equals -4. You might be tempted to say, yep, this doesn't have any real solutions, but remember we're in further maths and we allow complex solutions. The question doesn't mention it, but it's implied, which means we can take the square roots of -4, actually plus or minus the square root of -4, which is going to give us plus or minus 2i. Because when you square both of those, you'll get 4i squared, which will give you -4. So finally, we just need to write down all our possible f's. Remember, f is 2k, so it could be 2, 0, could be 2, 2i, or it could be 2 minus 2i. Got to make that really clear. Well done.